We're going to talk about resolution and file types today. So we're going to talk about the building blocks of a digital image and then how we can kind of put those building blocks together in different ways and the benefits and the drawbacks to that. So first of all, I want to talk about resolution and this thing that we call the pixel. And I know we all know what a pixel is, or maybe we think we know what a pixel is, but a pixel is not a specific size. A pixel size needs to be designated. So what a pixel is a single square that represents a single color or tone in a file. And when we're talking about the pixel, we're talking about this sort of fixed element within our image. So I've mentioned that in Lightroom, it's a non-destructive editing program, and that's because it doesn't actually manipulate the pixels in the image. It may look like it's doing that on the screen, but what it's actually doing is keeping a list of the settings and the changes that we make to the image, and it doesn't actually apply them to the pixels until we export it out. How that is beneficial is that once you change a pixel, it's hard to change it back to what it was. So with Lightroom, we're not changing it, which means we don't have to change it back. We can revert it back to what it was by removing the changes that we applied. But once we go into something like Photoshop or export it out as a file, those pixels get set, and that set pixel is the color that it is. And to try to get it to be another color can be problematic. So when we talk about the pixel and it not having a size, what that really kind of works out to be is that we designate what the resolution of our image is. We talk about resolution, we talk about pixels, and a lot of times people either leave out part of that equation because they don't quite understand what that equation is, or they leave out part of that equation because they don't have the details for that part of the equation. But in order for us to know how big a pixel is, we need to know how many pixels we have in an inch, right? So let's say that this square, the squares that I'm looking at here, these 6 squares, represent a 1-inch image. And so if we had a 2 pixel per inch image, that's what we would have at that 2x2 frame. Very low resolution, not a lot of detail at all in that image. And then as we step it up to a 5x5 grid, or 25 pixels in there, or 5 pixels per inch, then we end up with a little bit more detail, but still not enough detail to resolve what's in that image. But we can see that something is in there, more so than the 2x2 or the 2 pixels per inch. And as we step up to the 10 pixels per inch or a 10x10 grid, we now have 100 pixels. You can see that we're moving up exponentially here. We're now starting to see that maybe it's a letter, or at least we can make out a shape that it is. And then when we jump to 20x20 pixels, we have quite a bit more resolving power. And then as we continue on up towards that 100x100 or 100 pixels per inch, we now have enough resolving power to not only see what it is, but also have curved lines made out of little square pixels. So it's important when we talk about our images or the size that we want our images that we talk about either an absolute number of pixels. So you may recall that in the assignment, I asked for your image to be exported at 1500 pixels on the long dimension. I know what I can do with 1500 pixels because I know how many pixels per inch I can get out of what size I need to look at it. If you were to do it lower, you would get like this 25x25 pixel image. Again, lower resolution. As we double the number of pixels to 50x50, we get a significant increase in the amount of resolution. And then as we go way up to 400x400 pixels, we get a ton of information or detail in our image. So the more pixels we have, the more detail we can get. But we only need a certain number of pixels to look at things on certain things. When we're printing, we're going to need more pixels because printers need more information to make a better image. When we're looking at it on a screen, screens are 72 pixels per inch. And so you can think about the size you want to see it on the screen and make it at 72 pixels per inch, and you'll be just fine. So the things we need to know when we're designating a file size is either absolute pixel dimensions or dimensions in inches plus knowing how many pixels per inch. And so you can kind of multiply it out. Like if somebody said they wanted an 8 by 10 at 300 pixels per inch, well, that works out to be 2,400 pixels by 3,000 pixels, right? So they could say, send me an image that's 2,400 pixels by 3,000 pixels, or they could say, send me an image that's 8 by 10 at 300 pixels per inch. Now let's talk about file types. So we kind of understand a little bit more about the pixel and the building blocks of an image. Let's talk about how we put these images together and the formats that we use in order to capture these images. So far, we've probably been working in JPEG, or you've probably been working in JPEG for these assignments, which is totally fine because we haven't really started to talk too much about the raw files yet. But there's a file format that your camera can most likely capture, which is called a RAW file. And the RAW file is actually raw data. It is the information that hits your sensor that gets recorded. It's not an image until we run it through some piece of software in order to create that image. And that software that we're using this semester is Lightroom, Adobe Lightroom. The JPEG is an image and it's pixels and it's already saved and everything is sort of baked right into it and it's ready to go. So let's look at kind of a comparison of RAW versus JPEG. So with RAW, we get what's called a lossless compression, meaning it compresses the file, but it does not eliminate any detail. It looks for redundant pixels and it compresses those redundant pixels down. JPEG, on the other hand, is a lossy compression. JPEG will actually remove information from your image in order to compress the image more. So you may have noticed when you save to JPEG or when you export to JPEG, there's a quality slider, right? From 0 to 100 in Lightroom. That is how much compression you're applying to your image. You may have noticed in the settings of your camera that you have different JPEG settings. Like it may say large JPEG, but there may be two different large JPEGs. One was sort of a smooth curve on the curve next to the L, and another one was sort of a blocky curve. Well, the smooth curve is more detail, more information, and the blocky curve is less detail, less information. RAW files are captured in true 16-bit color. We haven't talked about color space and colors yet, but what I'll tell you is 16-bit color has more colors than we can perceive with our eye, which means that the software has the ability to sort of choose the best color to make it match more close to what we want to see in our image. They also have more detail meaning more information in our image that we can bring out with the software after the fact. And that is with these adjustments, which is we can adjust the exposure to a certain extent. We can adjust the contrast. We can adjust sharpness. We can adjust white balance. We can adjust not just the contrast, but we can localize it by highlights and shadows individually as well. We can adjust color balance. That's the white balance. The JPEG is ready when it's shot. It's done. The RAW needs to be processed afterwards, and the JPEG has preset adjustments. Those presets are determined by your camera. You can think of it this way, right? If you go to the store and you buy a package of cookies, chocolate chip cookies, you have chocolate chip cookies. They are what they are. You eat them, and that's what you got. You go to the store and you buy the ingredients for chocolate chip cookies, and that's more like a RAW file, where you can bring those ingredients back and you can make them maybe a little sweeter or a little less sweet. You can make them with more chocolate chips or less chocolate chips. You can add something other than chocolate chips. You can bake them a little bit crispier. You can bake them a little bit softer. You have a lot more options that you can use in that. So let's look at what JPEG compression looks like. So when we look at these images, you can see that when we zoom way in, there's not a ton of detail that's in there. It's part of this is about sort of viewing distance and where you're looking at this image from. So when we zoom in, we lose a little bit of that detail, but we can still make out what we're looking at, right? We can see that it's branches and that there's highlights and shadows and there's shape and there's branches between there. And that's at a 15% compression. So that's barely compressed. 85% quality. So that would be on that slider at about 85. if we went the other direction and we took that slider down to 15 and 85% compression, you can see now that when we look at this image up here, there's kind of these artifacts, right? There's these odd sort of colors and chunks and blocks of color that show up on our image. And that's because what the computer has done is sort of broken the image down into these grids. And then inside each grid, it's kind of said, oh, these colors are all about the same. I'm going to make them this color. The sky is all about this, close to this blue. I'm going to make it all that blue. It's just sort of reducing the file to the least common denominator in these grids. And this happens when you save your JPEG, which is when you shoot it. If you photograph a JPEG, when you take the shot, it's saving the JPEG, and that's when it compresses. And this on the left would be that smooth curve on your camera, and this on the right would be that blocky curve on your camera next to the JPEG indicator. If you take this JPEG and open it up in Photoshop and make some adjustments to it and then save it again, the computer is going to recompress that file. In other words, it's going to lose more information. And so you could continue to open and save your JPEG files a number of times until you basically eliminate almost all of the information. So we just need to be kind of aware of that when we're working with JPEGs. JPEGs are a readily used form of file management or file type. They're very versatile. Every image you see on the web, most of the images you see on your phone, they're a pretty widely used and versatile file format, but we just need to be aware of what can happen when we over manipulate a JPEG. So there's another file type that I just want to kind of introduce to you guys, and we're going to talk about it, and you'll see another demo on this as well. And that is the digital negative format, or DNG. This was introduced by Adobe in 2004. And what they were trying to do is really kind of create an open source, fully documented RAW format. Every camera manufacturer designs their own RAW format. And actually, some of them will design a new one with new cameras that come out. And so there is no standardized RAW format, meaning Adobe has to reverse engineer RAW formatting in order for you to be able to process your RAW files in Adobe software. So they introduced in 2004 this digital negative, and they wanted people to use it so that they would have this standardized version and that everybody would be able to access what a digital negative was and implement it into how they wanted to show their RAW files. That never really kind of took off. So what we can do now is we can convert these images in Lightroom. And the reason that we might want to convert them is that you'll end up with a DNG file, which is open source and will probably be more readily supported potentially for longer than your RAW files. So far, I haven't seen any RAW files that have stopped being supported, but that doesn't mean that it won't happen. So it might be beneficial to do them into DNGs so that you have potentially a little more longevity to your file. The other benefit is it can be a smaller file size than a RAW. It can compress the file a little bit more. And there's another benefit to it. It saves all of the settings in the DNG package. And I put package in quotes because it looks just like a DNG file. It is just a file, a single file. But inside of that file, it's kind of like, they call it a package or an envelope, is your raw data, your DNG data, a JPEG preview, and all of the settings or custom adjustments you have made to that image. It kind of packages all that together. You can also save the original RAW file in that package, but it will significantly increase, if not double, the file size. So in the next demo, I'm going to show you how to take a DNG or a RAW file into Lightroom and convert it into a DNG, and how to convert images you already have in Lightroom into DNGs. And as we move forward with any of our RAW adjustments, that will be working with DNGs, because DNGs work just like RAW files.